Welcome to Spark on PC. Today, we're diving deep into the world of computer hardware, the essential parts that make up your PC. Whether you're planning to build your first computer, upgrade an old one, or just want to understand what's inside your machine, this video is made for you. By the end, you'll know exactly what each part does, why it's important, and how all these components work together to create the computers we use every day. Let's start with the PC case, also known as the tower. It's the outer shell that holds all the internal components. Cases come in various sizes like full tower, mid tower, and mini tower, and your choice depends on how many components you plan to install. Beyond just appearance, a good case provides proper airflow, cable management, and easy access to internal parts. Modern cases often include dust filters, tempered glass panels, and front USB ports for convenience. So while the case doesn't affect raw performance, it plays a big role in your PC's cooling and overall look. Every component needs power. That's where the power supply unit, or PSU, comes in. The PSU converts AC power from your wall into DC power that your components can safely use. Power supplies are rated in watts, and it's crucial to choose one that provides enough power for your CPU, GPU, and other devices. For example, a high-end gaming PC might need a 750 or 850 watt PSU, while a simple office PC could run on 400 watts. Look for 80+ certified power supplies. They're more energy efficient and produce less heat. Next up is the motherboard, often called the heart or central nervous system of your computer. Every part connects here: the CPU, RAM, storage, GPU, and even the fans. It allows all components to communicate. Motherboards come in different form factors: ATX for full-sized builds, micro ATX for mid-size cases, and mini ITX for compact systems. They also determine compatibility. You can't install an Intel CPU on an AMD motherboard, and vice versa. Most modern boards include built-in Wi-Fi, Bluetooth, RM2 SSD slots, and RGB lighting control. Choosing the right motherboard sets the foundation for your build. Now we come to the CPU, or Central Processing Unit, the brain of your PC. It processes all instructions from your software and hardware. Modern CPUs like those from Intel or AMD contain multiple cores and threads. A single core handles one task at a time, while multiple cores allow multitasking, like gaming while streaming or editing a video while rendering in the background. CPU performance is measured in clock speed, gigahertz, and core count. For example, an 8-core CPU at 4 GHz can handle demanding tasks more efficiently than a 4-core CPU at 4 GHz. There's also a small chip of thermal paste and a cooler mounted on top to keep it from overheating. Choosing the right CPU depends on your needs: gaming, editing, programming, or general use. Next is RAM, or Random Access Memory, your PC's short-term memory. It temporarily stores the data that your computer is currently using. More RAM means your computer can handle more tasks at once, like opening multiple browser tabs, editing a video, and running a game. All rely on RAM. Today, 16 GB is ideal for gaming and general use, while 32 GB or more is great for creators and professionals. RAM speed, measured in megahertz (MHz), also affects performance. Faster RAM helps your CPU access data quicker. Storage is where all of your files, applications, and operating system live. There are two main types: hard disk drives, or HDDs, mechanical drives with spinning platters, cheaper but slower, and SSDs, or solid-state drives, faster, silent, and more reliable because they have no moving parts. An SSD can boot Windows in seconds and open games instantly. Some SSDs use the M.2 NVMe interface, which offers lightning-fast speeds compared to older SATA drives. For the best setup, most people use an SSD for the operating system and games, and an HDD for extra storage. Now let's talk about the GPU, or Graphics Processing Unit. It's the part responsible for rendering images, videos, and 3D graphics. If you play games, edit videos, or work with 3D design, your GPU is doing most of the heavy lifting. While CPUs handle general computing, GPUs are specialized for parallel processing. Popular models come from NVIDIA and AMD, with dedicated cooling systems and their own memory known as VRAM. Every component generates heat, so proper cooling is essential. There are two main types: air cooling, using fans and heat sinks, and liquid cooling, which circulates coolant through tubes and radiators. And that's your complete overview of PC components. Now you understand what each part does and how they come together to power your computer. If you found this guide helpful, hit the like button, subscribe to Spark on PC, and stay tuned for our next video.